Today we're going to be looking at some basic exponent rules. So we're just going to start out with what is an exponent. So when we're using exponential notation, we use this to help us with repeated multiplication. So if I am multiplying 5 2's together, I can write that in a more concise form as 2 raised to the 5th. So 2 is what we call the base, and then the 5 is what we call the exponent. Okay, so if we make that more generic, a to the n, then a is the base. That's the thing that we're multiplying. And n is the exponent. So that's the number of times that we're multiplying it. Okay, so for our first two examples, we just want to change these to exponential notation. So our base is x. We're multiplying it together 4 times, so x to the 4th. 1, 2, 3, 4, 5, 6. That would be 4 to the 6th. Now I want to make a little note right here. Sometimes you'll hear me say 4 x's. If you have the 4 in the front, if you have 4x, that also means 4 x's, but they're added. So 4x would be repeated addition of the x, whereas x to the 4th is repeated multiplication of the x. So it's easy to get those two mixed up. All right, so if I'm asked to evaluate 4 to the 3rd, that means 4 times 4 times 4. So that would be 16 times 4, or 64. 9 squared means take the base of 9 and multiply it 2 times, so 9 times 9, that gives us 81. 17 to the first power means take the base of 17, and we only have it 1 time, so the answer is just 17. So if we're thinking about this as a count, we run into a problem when we get to number 6. So how do you multiply 5 to itself 0 times? Well, this one is a little bit different than what you might think. If you go down to the very bottom of this page, you're going to see the 0 rule. And it says for a not equal to 0, a number raised to the 0 power is equal to 1. So we'll talk more about why it's 1 and not 0 in the next video. But for now, we have that rule. So we can go back up to that example, and we see something raised to the 0 power is going to equal 1. All right, our last two examples deal with negatives. It does make a difference whether the negative is in parentheses or out of the parentheses. So for number 7, the negative is in the parentheses, so my base is negative 2. So if it's in the parentheses, it's going to repeat. That means take negative 2, multiply it to itself 2 times, and that gives us a positive 4. All right, now if I look at this last one, notice the negative is on the outside. Sorry, my cats are fighting. All right, so I've got a negative on the outside, and then only the 2's are repeating. So notice the negative didn't repeat here because it wasn't in the parentheses. And that's going to give me an answer of negative 4. All right, so we've talked about when the exponent is 0. Now let's talk about when the exponent is negative. So if I take, for example, number 3, and I want to raise 3 to the negative 2 power, it doesn't make any sense to think of this as a count. I can't multiply 3 to itself negative 2 times. So a negative and an exponent has a very different meaning than a negative and a whole number. So what it's telling you to do is if you see a negative exponent, it means that that base needs to be moved to the other part of the fraction. So if it's a negative exponent in the numerator, it will be positive in the denominator. So if we look at these first two, x to the negative 3 simply means 1 over x to the positive 3. Okay, let's go ahead and do this one since that's number 2. So 2 to the negative 3, the common wrong answer is negative 8 because 2 to the 3rd is 8. But remember, my base is positive, so I can't multiply a 2 and get something negative. So 2 to the negative 3 means 1 over 2 to the positive 3, and that gives me 1 over 8. So the negative exponent doesn't make your answer negative, it simply moves that base. So 3 to the negative 2 would be 1 over 3 to the positive 2, so that gives you 1/9. 5 to the negative 3 becomes 1 over 5 to the positive 3. That's 5 times 5 times 5. I end up with 1 over 125. All right, now let's look at our last two. These are a little bit tricky. I definitely want to move the x's, but notice we have this 2, so we have to figure out what to do with it. The 2 does not have a negative exponent. There's 1, 2, so we could think of that as 2 to the first times x to the negative 2. So what I want to do is I only want to move the negative exponent. I don't want to move the 2 because it has a positive exponent. So what I do is I leave the 2 and move only the x's to the bottom, and that becomes 2 over x squared. So when you have a product, you can move some pieces, some factors, and leave others. All right, now this last one, we've got a couple of negatives going on here. So let's start with this negative. I know a negative exponent means to move it to the bottom. It doesn't change my base. My base is still a negative 2. That's just a negative number, so it stays a negative number. The only thing that changes is the sign on the exponent. Then if I take negative 2 to the third, that's negative 2 times negative 2 times negative 2. That gives me 1 over negative 8, or I could write that as negative 1/8. So those are both the same thing.